Hi, I'm John Paul Raj, and in this particular video, we are going to continue to solve question number 1 from paper 3, May 2025, IB Mathematics Applications and Interpretations. This is the time zone 1. Let's get going. So prior to collecting data, Augustine believed that the mean result for school B was higher than that of school A. This is what his belief was, that the mean result for the group B was, or the school B was higher than that of school A. From his data, he finds that the mean final exam result for the sample from school B is exactly 60. Now remember, we got to refer back to something that we did earlier, which was in the previous video. If you missed that, you'll get the link, that card somewhere, where did it come? Maybe in this corner? Yeah, somewhere it comes, all right? Just go and make sure you see that. It's also there on the playlist, okay? So everything that was done in the previous previous video has to be used or referenced in this video again, all right? Because here's where we are actually performing the test, okay? Everything was set up in the previous video. State appropriate null and alternative hypothesis for the pool t-test. We already established in the earlier video. You can go and take a look at it. That's what I meant. Why we're using the pool t-test. In this particular video, we're just going to use it and show how it is to be used. So the pool t-test we want to use, and it says that Augustine believed that the mean result of school B was higher than that of A. So mu B, if that was the mean result, exam result, or the final exam result from B, school B, then mu B must be greater than A is what we're saying. The null must be something like, it's just equal, there's no change, and then obviously it's being challenged by this particular sample that they are looking at. Okay, so this is part E, part 1. I'm just going to write it up here, okay? Or shall I just go across? Maybe that's a better idea. Let me just go across. So this is, just draw a line here. 1E, question 1E, and we say part 1, and we can say that they asked for the, I keep forgetting so quickly, appropriate null and alternative hypothesis for the pooled t-test. Okay, so we'll just write down the pooled t-test, and the null hypothesis is mu A equals mu B, all right? And the alternative hypothesis is the fact that you can either write it mu A is less than mu B, or if you want to write it as mu B is greater than mu A, because that's what his belief is, all right? And if you want, maybe it's a good idea, you can also write down where mu A and mu B represent the, let's use the words, okay, the terms from the exam. It's the mean result, right? The mean, is there anything specific that they mentioned? Let me just check that. Mean final exam result, okay? Mean final exam result represent the mean final exam result from school A and school B respectively. Okay, this part you got to, because we're using the symbols, right? And the symbols were not there, not part of the question. They've not used those symbols in the question. So since you're introducing it, it's a good idea to explain what that means. Okay, so that's the null and alternative hypothesis, alternate hypothesis, E part 1. Find the p-value. Okay, so we'll use the GDC now. So E part 1 is done. So I can just write down using GDC. E part 2 using GDC, and let's just make sure that we write down the input as always. I'm just going to switch to my calculator, and here we go. It's a pool t-test, and I'm going to go through menu, statistics, and stat tests, and to sample t-test. Okay, to sample t-test, make sure you're there. And the input method, this is not data, because yes, I know the first one we did through that list, but we are using the stats because both the lists are not there, both the data is not there. So we're going to use stats, okay? All the stats that is accumulated from the first test, which is then my list and spreadsheet here. If you know what I'm talking about, this was the first list. This was from school A, and we found the I think this sample standard deviation, we got it from here, and all that stats from that first list is there that was available to us. But for the second school, they don't have, they just have given the statistics, okay, which is why our input method is going to be just stats and not data. Okay, so stat test to sample t-test, and we are going to use the data input method as stats. All right, now let's be careful how we're entering these values here. What did I find in the earlier one? Let me just quickly check that. The mean for the school A was 51.7, so that goes here, 51.7. okay, the sample standard deviation for the first one, which we found in part B, question number 1, part B, we found 7.60. So I'm just going to enter it as 7.60. Sample size was 6. Okay, x bar 2, they've mentioned in just in this part, right? They've just mentioned it very clearly that it's 60. They've said that, you know, from his data, he finds that the mean final exam result for is exactly 60. Can you see that? So we're going to enter 60 here. Okay, so coming back to my calculator, this is going to be 60. And then they've said, I think this was also given in the question earlier on. Can you see that? They've said that it's 7.66. The value of Sn minus 1, the sample standard deviation for school B, 7.66. So we're going to enter all those things here. 7.66. And this is also 6. Okay. And when you come down, what's the last one? Okay, alternate hypothesis. We are saying that mu2, by the way, they called it mu2. We've called it mu b. Obviously, that should be greater than mu2 should be greater than mu1. Okay, that's my alternate hypothesis. Pooled, yes, it's pooled. We are taking it as pooled. All right. Hit OK. And before we do, let's just check it one more time. And I'm going to write it down. Okay, so every input, what you do, make sure you write it down on your answer scripts. Okay, so that you know you're just not writing using GDC. You're actually writing down how you're using your GDC. That's the idea of writing down the input. So everything that you see on the calculator. Okay, so I'm just going to write in 2 sample t-test, and every input that goes along with it, x1 bar equals 51.7. So you can, so that you can see what I'm writing, I'm just going to show it to you quickly, right? Exactly what was seen on the calculator screen. X1 equals 7.60, N1 is 6, then X2 bar is 60, and SX2 is 7.66, and what do I have? N2 equals 6, and obviously you just scroll down a little bit. Okay, alternative hypothesis. You can write that thing down as HA as you're seeing it. Okay, just write it on as you're seeing it, mu1 less than mu2. So you know, people will know, examiner will know that you're using, you know, let's say this is a TI-Nspire, so obviously the syntax refers to that. Okay, in some other video we'll try and see how this is done even through the Casio. So you know, you should know how it is done with the Casio also, and most importantly, you should know that, you know, I'm not biased to any one particular calculator. It's just that I've used this so often, I'm more familiar with the TI, but you know, we can do this thing with the Casio also. So anyway, I have shown you using GDC, you've written down what the syntax is, and now we'll switch back to the calculator, just see the results. Okay, so and hit OK here, and once we do that, everything is calculated for us. We're just interested in the p-val, remember, that's what the question says. All the other data is there, but just to double check whether the rounding off is okay or not, you know, I'm familiar with the TI, that's why I'm saying that. Okay, so let's just go to the var. This is where all the stats will be stored. So we come here, can you see that p-val? Okay, so the p-val, when you hit that, it will give me all the digits. Okay, so when I hit enter, you'll get that, and we can recall that to figure out what that rounding off was. So it's 0.00445. I would make it, yeah, up to 3SF, right? Up to 3SF is what we're required to write. So I'll do that because as you can see, it just gives you those digits, and to be sure of what the 3SF, whether it was actually rounded out to 3SF or not. And believe me when I say that, as much as I've used this for such a long time, because I've used it for such a long time, this particular calculator, I will do some other videos with Casio also, don't get me wrong. For those of you think that, you know, it's not that I favor any one particular calculator, I'm just more familiar with it. And because I'm familiar with it, even though the settings are 3SF, you know, I still make it a point to check the rounding off, because it has let me down. It has let me down. So having said that, I'm just going to jump back to my answers here and write down that the p-val Okay, the p-value, as we can see, up to 3SF, we're going to write it as 0.044, and I'm going to write it as 5, okay, up to 3SF. Now, did they just say p-val, or did they also say conclude? They said find the p-value. So we're done with that part, okay? And then the third part says, given that the test is carried out at 5% significance level, state the appropriate conclusion in context. In context means not just saying that we are going to, reject or not reject, not that, but in the context of the question, using the vocabulary of what's going on, what's the study, all that kind of stuff. That is what's meant by in the context, okay? So, at 5% significance level. So what do we have? It is less than, right? Yeah. So this is part 3. I'm just going to write it under that. Since p-val equals 0.0445 is clearly less than 0.05, which is the significance level. We have sufficient evidence at the 5% significance level to reject the null hypothesis H0. Now, to be on the safe side, I would say write it down, because if you're not able to frame it correctly, they might be a little considerate, because context means not just leaving it just at this. You know that we want to reject the null hypothesis. The null hypothesis said that, there is no difference, right? There is no difference when you say mu A equals mu B. There is no difference. That was the status quo as to say, okay, there is no difference in the mean final exam. But the alternate hypothesis says that, the mean final exam result from school B is greater than, and so there is sufficient evidence to reject the idea that, and we'll write down, okay, this means, how do we write that? So we reject the idea that the mean exam results from school A and school B must be equal, are equal, okay? Yeah. So basically what you're saying is that we have sufficient evidence to reject the idea, okay, at the 5% significance level. So we are rejecting the idea. We're not saying that we're going to accept it, all right? That might not be the accurate statement. Don't say that we accept the alternate hypothesis, okay? So rejecting the null does not necessarily mean accepting the alternate, okay? These are the... this is why these small terms about significance level, the sample, remember we already said that the sample size is small. So all those things come into play based on the same sample. So if you want, you can even clarify that, okay? Reject this idea based on the sample size and 5% significance level. Okay, so you can say that as the conclusion. All right, let's keep going. What do we have next here? All students in these two schools took the same entry exam at age 11. Okay, so there's some other exam that they've taken at age 11. There's an entry exam, all right? All the students in the two schools, school A and school B. Augustine now wants to determine if there is evidence of any correlation between that exam, that entry exam result, and the final exam result. For the 12 students in the sample, Augustine collects their entry exam results. This Augustine, man, you're a champ. The Pearson product moment correlation coefficient between the results for the entry exam and the final exam is R is equal to. So this is the correlation coefficient, trying to see whether there's any correlation between that entry exam and this final exam result. Okay, and the correlation coefficient that he got was R is equal to 0.876 to 3SF. The critical value for R at the 5% significance level is 0.576. Okay, So what does the question say in part F? It says, assuming all requirements are met, perform a test at the 5% significance level. Okay, now we are looking for the test with rho. Okay, again, remember always whenever you write the null and because that's what they're saying. State the hypothesis and justify conclusion. Whenever you write the null and the alternate hypothesis, you're not using the sample statistics. You're going to be using the population statistics, and so R is the sample correlation coefficient. You got to be referring to the population correlation, which is indicated as rho. R, H, O is the Greek letters. This is part F, I believe. So I'm just going to draw a line here. We're just going to draw a line here. And okay, and this is question number 1, part F. And they said to write the null and alternate hypothesis, right? So null hypothesis is going to be rho equals 0, suggesting that there's no correlation. There's no correlation, okay? Because what are they saying? They're saying that assuming all requirements are met, because what is he trying to say? Augustine wants to determine if there is any evidence of any correlation. If there's evidence of any correlation, is there a correlation? Every time that's the thing that we use in the alternate, that there is a correlation, and there's no correlation. Typically for the sample, whenever we did any kind of questions on sample, we say R. This is rho, the Greek letter, talking about the population correlation coefficient. Okay, so you got to use rho there, and we say rho is equal to 0 and rho is not equal to 0. Have they asked just the hypothesis? Yeah. So we'll just write down H1 should be rho not equal to 0. So this means that there is no correlation, rho is equal to 0. This means that there is a correlation, okay? And again, we can write down what that rho represents, where rho represents the population correlation coefficient. Okay, if you want, you can write it more specifically as Pearson product moment. I think that they mentioned there. Okay, so but you can just say, maybe just write it down. Okay, population correlation coefficient. If you want, right, you can add Pearson product moment correlation coefficient. Cool. So you said that, rho is equal to 0. You said rho is not equal to 0, suggesting that, null is that there's no correlation. Alternate is that there is some kind of correlation. And you've clearly said that the rho represents the population correlation coefficient. All right. What's the next part in F? F part 2 says if the requirements... Oh, no, we need to justify the conclusion. Wait a second. We need to justify the conclusion based on what they've given, right? So from the sample, for those 12 students, R is equal to 0.876 and the critical value at the 5% significance level is 0.576. 876 is greater than 576, okay? That is a clear indicator that we're going to reject the null, okay? That's a clear indicator. So that's what we need to justify. So we can write that thing down also, that from the sample, since R equals 0.876 is greater than 0.576, which is the critical value. We have sufficient evidence at the 5% significance level to reject the null hypothesis H naught. And remember what the null hypothesis. The null hypothesis said that there was no correlation, and now you're saying that at the 5% significance level you are actually rejecting the idea that there is no correlation. In other words, you're saying that there is a correlation between that exam, what was it, that entry exam, there is some correlation between the results from the entry exam and the final exam result. That's what you're suggesting. If they ask in context, they didn't say anything. Just state your conclusion. So you can say that in the context if you want. You can just write that thing down, which means that we have sufficient evidence at 5% significance level. So much to write. Yeah. Which is why I keep saying practice writing. Don't just look at solutions. Practice the writing, because writing takes time, okay? As you can see, we have sufficient evidence at the 5% significance level to reject the idea that there is no correlation. That's important. There's no correlation. I think my spelling for correlation is incorrect. Correlation between the entry exam results and the final exam results. I think that should be good. All right, that should be good. So basically you're saying that there is a correlation. All right, I think that's all the time that we have for this particular video. If you found this video useful in any way, please make sure that you like this video, share it with a friend, and subscribe to my channel. If you visit my channel, there are several other videos there. Do make sure you check them out. And if there's any concept, any topic that you'd like explained, do mention that in the comments and I will make a video for you.